my first video, and today we'll be solving the problem, today's lead code problem, rearrange k substring to form the target string. Now let's understand what the question wants to say. You are given two string s and t and both are anagrams of each other. Now what is an anagram? If count of count of each character in both the strings is equal, then they are anagrams of each other. For example, let's take this second example. Now the count of A is 2, the count of B is 2, and the count of C is 2. Okay, now if the count of each character is equal, then we can say this is both are anagrams. So count of B is 2, count of A is 2, count of C is 2. So the count of B in both strings is equal, the count of A in both string is equal, the count of C in both string is equal. So these two are anagrams of each other. Okay. Now let's see each and an integer k. We have been given two string s and t, both are anagrams of each other, and an integer k. What we have to do, our task is to determine whether it is possible to split the string s into k equal substrings and rearrange them, concatenate them in any order to create a new string that matches the given character t. Now what is this trying to say? We have to divide the string into k equal size substring. So we have k here is 2, so we have to divide this string into two equal parts. So this will be AB and CD. Now we have to rearrange them in any order. For example, let's say I took CD first and AD after. Can I form this string? Yes, I can form this string. Now let's take the second example. We have to divide this string into three equal size substring. So let's divide AB, BB, CD. Now we have to rearrange them. How? There can be a number of possibilities to rearrange them. Let's say CC, BB, AA. This is also a rearrangement. We can say CC, AA, BB. This can be also possible rearrangement. Let's say BB, AA, CC. This is also possible rearrangement. Let's say AA, CC, BB. This is also possible rearrangement. There can be many possible rearrangement for this. Our task is to find whether in all of these rearrangements there exists a rearrangement that is equal to this string. So we can say BB, AA, CE. This exists in our rearrangement. We have to give true if their rearrangement exists and false if don't exist. Now how do we solve this problem? Let's divide this second string as well into k equal size substring. So what will be the sequences? BB, AA, CC. So we have to check that all of these rearrangement is present. Like before that, let's understand. Let's erase this up. Now, how do we know whether it will be possible that any rearrangement exists that will form these strings, right? So we divide these strings into k sized equal string substrings. So let's divide like that, and this is AA, BB, CC, right? Now we'll also divide this string BB, AA, and CC, right? This is the division. Now if I have to rearrange these string into this string, then every substring should be present in this set. Every substring should be present in this set. So there is a BB, so there should exist a BB in the S1 string also. There exists a AA, so there exists an AA, so there should be an AA present. If there exists a CC, then there should be a CC present in that, right? Let's take this example. If we divide this will be AB and CD, and this will be CD and AB, right? If there is a CD, so there should exist a CD in S1. If there is AB, then there should exist an AB. So this can be in any permutation. If we rearrange, there can be formed there should exist a permutation that will be equal to this, right? But let's take the final example. We have to split the string into two substrings. So let's AAB and BCC and BBA and ACC, right? So do BBA exist in S1? No, there is no. So no matter what permutation I try, A, let's say B, B, C, A, B. I guess these two will be the permutation. No matter what permutation I try, I could never form this string. Why? Because this substring is not present in this set, right? So what will I have to do? I have to just divide the strings into k equal size and put it in a hash map and check and divide this string as well and put it in a and check with that hash map whether there exist all of these number of string in the first in this set, right? So what we'll have to do, we have to generate all substring of n by k size in S1. What is n by k size? What is n by k size? Why we have to generate this in n by k size? Here, like suppose I have to split this A, B, B, C, C strings into k strings, or example 3 strings, 3 equal strings. So these are 6 character. If I have to make 3 substrings, then each character will be of 2 size, which is equals to this. Suppose we have 6 character and we have to give it to 3 people, so each people would have 2 characters, right? So that's how the size is. Generate all strings of n by 1 n by k size in S1 and put it in hash map. Put in hash map. The next task is to generate all substring of n by k size in S2 and check if it exists in hash map. It should already exist in hash map. If it does, we'll just decrement the count. If it don't, we'll just return, right? And finally, if these statement do not returns, so we'll just return with a true, and this indicating that there exists a pattern. Now let's look at the code for this. Now we have been given this. We have been given 3 objectives. You have to first generate k substrings of size n by k in S1, and we have to generate k substring in size n by k in S2 and return the value, right? So let's code it up. Now we'll have an n which contains the size of the string. Now we'll have a size variable which tells me the size of each string, which is n by k, right? We'll have an unordered map. It will be of string comma integer, where will be stored the count of each substring, right? Now if for generating the substring, we'll run a loop from I is equals to 0 till the length of the string I plus plus, and we will have a temporary string which is, and we'll extract the substring which is s dot sub str. This is a function to extract the substring. Now we have to give the starting index followed by the size, how long we have to get the string. For example, if my start, this is the string and this is my starting, so this will be 0 1 2 3 4 5. So 2 would be my starting index, and how many characters I need, I'll to tell that. So I need 2 characters, so I will call a sub str function like that. Okay, index, starting index followed by the number of characters you want in the substring. So we have size variable for that. Now we'll not run this, we'll add it by size. Since we are taking it, we do not want to repeat the same substring again and again. and we'll put it into the map, increase the frequency. Now we have generated, we'll now generate k substrings for s2. So int I is equals to 0, I is smaller than n, and I plus is equals to size, right? String temp is equals to t dot sub str. We'll give the starting index, we'll give the size, right? Now if the value of temp is equal to 0, then there it means two things: either the string do not exist, or all the strings of substring of that sequence is already used. So we'll return a 0, else we'll just decrement the size, right? And if this loop do not returns me a 0, then I can simply say that we can form the permutation. Now let's submit it up. It has been submitted. Let's thank you for watching.